Saxon Algebra 1, Lesson 9, in that it's word problems where we're building systems of equations, but instead of always having a straightforward quantity statement, value statement, we're going off the grid in terms of our two equations. They might not fit that quality or quantity volume. Oh my gosh, I can't talk. They might not fit that old value paradigm we've been using for the coin problems, the dress shop problems, it's the $30 first class tickets to nowhere, because that doesn't exist in real life. But in any case, these equations are going to be a little more freeform, but it's okay, they're not that harder. Again, they're not that much harder. What we're looking for are things that are equal to each other so we can create statements. So let's look at example 90.1. Together, Charlie and Nellie picked 92 quarts of berries. If Charles picked 6 more quarts than Nellie picked, how many quarts did each of them pick? Okay, so we can see the variables here are going to be the number of quarts that Charles picked and the number of quarts that Nellie picked. Together, they picked 92. There's a statement. The number that Charles picked plus the number that Nellie picked equals 92. And Charles picked 6 more quarts than Nellie. So the number that Charles picked is greater than the number that Nellie picked. And the difference is 6. So if we add 6 to Nellie, we're good. There it is. There's our two statements. They didn't really have a value type statement. So it's almost easier because we don't have any wonky prefixes on our variables, right? We don't have any weird numeric components there. We just have letters. Okay, so now we can do this either way. Oh, and remember here, these are the tricky ones, right? Write it as an inequality first. We knew that Charles picked more than Nellie, and then we find out how many more, and we can see, okay, we have to add it to the smaller side. The temptation is always to say, oh, he picked 6 more, so him plus 6. No, that's wrong. She needs the 6 more in order to be equal to him. So write the inequality first and then fix it. And we'll practice that. We have 6 problems in this lesson. Holy moly, we gotta run on problems here. Okay, so now we solve. We can see, oh, this is all set up for substitution, isn't it? We'll just plug this in there. So the number that Nellie picked plus 6, right? That's the substitution in there. Plus the number that Nellie picked equals 92. And now I don't use them to show the substitution. I can combine these two and subtract the 6. 2 times the number that Nellie picked equals, what would that be? 86, right? Because then that would add up. Okay, beautiful. I like it. So we divide both sides by 2. And we get that the number that Nellie picked equals half of that, 43. And the number that Charles picked, see, if they have to add up to 92, so it's almost 50, it would be 49, right? It's almost 50. If it was 50 exactly, then Charles is 50 plus her 43 would be 93, but it's only 92. So it can't be 50 for him, it's got to be 49. That's how my brain did that. Those add up. Let me just double check. 2, carry the 1. Yes, that adds up to 92. So I feel good about it. Let's see what the answer says. And the question I review is how many quarts did each of them pick? 49 and 43. Yay. Jonathan. Okay. Let's plow on. The number of boys in Sarah's class exceeded the number of girls by 7. Okay, the number of boys is greater than the number of girls. There's our inequality. We know that 7 is the number that makes them balanced. So we can see this side is already larger. So we're going to have to add the 7 over here in order to make this balanced. add it to the small side. Okay, if there were a total of 29 pupils in the class, how many were boys and girls? Oh, well, we know how to do that. Number of boys plus the number of girls equals 29 total. Okay? Again, we're all set up for a brilliant substitution here. We'll just put this in there. So I'll use parentheses, number of girls plus 7 plus the number of girls equals 29. We can take off these parentheses because we just used them as a bucket for that. We'll subtract 7. And we get 2 times the number of girls equals 22. And so the number of girls equals 11. And the number of boys, number of girls plus 7 equals the number of boys. This first equation helps me. It is going to be 18 for the number of boys. Correct. Let me put, I didn't do that when I wrote it, but I want you to remember that we are creating systems of equations. We have 2 variables in each problem, and so we need 2 equations in order to solve them. And we get those equations out of the words, and then we use either substitution or elimination to solve. Both of these have been set up beautifully for substitution, so that's what I've chosen. But elimination will work too. You'd have to do a little bit more work to make it happen, but elimination could get you the same answers. Okay, let's flip the page. .3. Are you having fun? I'm totally digging it. Philip cut a 38-meter rope into 2 pieces. The long piece was only 9. The long piece was 9 meters longer than the short piece. Okay. Now, and you could really do this with any problem. John's going to make it simpler. He's going to say the long piece plus the short piece equals a total of 38, right? Because it was a 38-meter rope and he cut it into 2 pieces. One's longer and one's shorter. Cool. How much longer? The long piece was longer than the shorter piece. Whoops, that shouldn't be an 8, it should be an S. The longer piece is greater than the shorter piece. The long piece was 9 meters longer. So if we add the 9 meters to the shorter piece, then those should be equal. What are the 2 lengths? Oh, I fixed it, so I can write that now. Does that make sense? Longer piece is greater than the shorter piece. 9 is the number that balances, so if we add 9 to the lesser side, original inequality, then we can change it to an equal sign. There we go. I'm going to substitute again. There's my 2L, so I'm going to put this in right there. So we have S plus 9 plus S equals 38. All right, I can take my parentheses off. These are both S's, so we get 2S. I just want to make it a 9 every time. Equals 29, right? 9 plus 9 is 8. I'm just double checking my subtraction with addition. 1 plus 2 is 3. Okay, we divide both sides by 2. Oh, John, what have you done to us? The length of the smaller piece of rope is 29 over 2, which I'm going to write as a decimal number. It would be, let's see, that would be 28. It would be 14.5. I just converted that to a decimal number in my head. And for some reason I want to do decimal numbers because it's easier for me to visualize in this respect. Okay, and then the longer piece, well, they're going to have to add up to 38, right? So I'm just going to write the 38 here, and I'm going to subtract. And so I get 23.5 5 meters for my longer piece. Let's just mentally add these. 5 and 5 is 0, carry the 1. 5, 6, 7, 8, 38. Okay, that adds up to 38, as it should, because they should total 38. And that's the correct answer. Okay. John did not use a subscripted variable. I could argue that anytime you want to just use the main letter, it really will work. Just do what makes sense to you. If you're fine, use subscripts. If you like to use just a plain letter, you can use those. If at the beginning of a problem, for a while, you just want to see what John uses for his variables so that your solution will look like his solution. If you need to go back to the solutions manual, that's fine. I'm fine with that. But just know that setting up your variables, as long as it makes sense to you, it'll be fine. The sum of two numbers is 72. The difference of two numbers is 26. What are the numbers? Okay, because we're subtracting, I'm going to use larger and smaller. Okay? In adding, it doesn't make any difference. It says the sum of the two numbers is 72. Sum means adding. The difference, and that equals 26. Okay? I use larger and smaller. I could have just used X and Y, but I wanted to use L and S because for the subtraction, that will make sense to my brain more if I think of the larger number minus the smaller number. Okay, these make a beautiful little system that is all ready to eliminate, isn't it? So 2 times the larger number equals, we're adding these, it would be 98. 45, it would be 49, wouldn't it? So the larger number equals 49. And then the smaller number, see, they have to add up to 72, right? So, what will help me do that? It has to add to 72, so this needs to be a 3. That'll make 12. There's the 2. Carry the 1, there's 5, so then I would need 2 more. Does that make sense how I did that? Let's see if it's right. If it's right, these should add to 72. And they do. Okay, so this is my answer. 49 and 23. Yay, John agrees. Okay. Notice that the equations that we're creating are pretty straightforward, and the solving of them comes out pretty fast too. This one was a little dramatic with the decimals. I was not necessarily in love with that. But what we're really practicing is taking the words and converting them to the equations. The equations themselves are pretty dang easy to solve. So it's all about turning the words into equations that is challenging us. 90.5. We have 2 more to go. The greater of two numbers is 16 greater than the smaller. All right, let's use G and S for greater and smaller. The greater number is greater than the smaller. Okay, how much greater? It's 16 greater. So we can see this number is already bigger. We have to add the 16 to the smaller side because that's what the inequality is telling us. Once we add the 16, then we can say they're equal. When added together, their sum is 4 less than 3 times the smaller. Oh, shoot. Okay. So when we add them together, their sum is 4 less. Okay, so that's it's less than 3 times the smaller number. When added together, their sum is, oh, I did it the wrong way. I wrote a greater than. It should be less than. Their sum is less than 3 times the smaller. That's an S, not a 5. Okay, so to make this balance, we're going to have to subtract 4. Because this side's already greater than, right? So we'll make that equal. two equations. Now, this one could stand to be cleaned up, couldn't it? Let's subtract the 3s. So we get the letters all on one side. This will be g minus 2s. That goes away, equals minus 4. And then this one's all set up to substitute. This is A, if you will. We can call them by name. This was B. This is also B, fixed up. Okay, so let's take this expression for G and plug it in right there. So we'll have S plus 16, that's this, S plus 16, which is equal to G, minus 2S equals minus 4. Okay, we can subtract 16 from both sides. This makes me a little nervous because I'm going to get a really negative number, but that's okay. It'll be fine. S minus 2S, we're combining like terms, that's just minus S, right? This is 1 minus 2, that would be negative 1. So minus S, that cancels, equals minus 20. Oh, I'm feeling better about this, are you? Divide by minus 1, and we get S equals positive 20. All right, that feels good. I like that. And then the greater number, we look back at our equations, S plus 16 equals the greater number. So the greater number now it must be 36. Let's test it and see if it's true. The greater of two numbers is 16 greater than the smaller. Yes. When added together, I don't want to do all that, never mind. No, I'll do it. When added together, their sum, 56, is 4 less than 3 times the smaller number. So what we're doing is this, right? G plus S equals 3 times the smaller number minus 4. 4 less than 3 times the smaller number. This is 60. 60 minus 4. It works. Check. True. Yay, it worked. This is the right answer. Okay? So these problems are also super easy to check. All right? Last one. 90.6. Here we go. The ratio of two numbers is 5 to 4, and their sum is 63. What? Okay, ratio means like a fraction. So if you want to find the ratio of number 1 and number 2, the ratio of two numbers equals 5 to 4. That's how you write that. The ratio of two numbers is 5 to 4. Just let it soak into your brain. It's a little weird, but this is how you write numbers as a ratio, and so here we created the ratio with letters, and there it is with numbers. The sum of the numbers is 63. So our other equation is n1 plus n2 equals 3. What are the two numbers? Okay, so this is A, this is B. System. I don't want to leave this in this form. I want to cross multiply right away. Get rid of this. So we have 4 times n1 equals 5 times n2, right? That's the next step of that. All right. John's solution shows how he sets up the two equations, but he doesn't show an option to solve it rather. Okay? So what I'm going to do is I'm going to make both equations fit this format, and then I'm going to eliminate them just for something different. Okay, so here I've got an equation. I'm going to subtract this because I want to move it onto this side. So I have 4 times n1 minus 5 times n2 equals 0. Okay, I'm going to write that under here because now they're in the same format, right? Oh, this is minus, sorry, not a plus. Minus 5 times n2 equals 0. Okay, so I'm going to multiply this one by 5 so that the n2's will cancel. Okay, so this is our new b. A, sorry. Now I'm going to fix b. 1 plus 5 times n2 equals, let's see, 5 times 6 is 30. 5 times that is 15. So I think this would be something I should write down over here so you can all see what I'm doing. 15, 31, 315. Add these together. 9 and 1 pencils equals 315. Divides by 9. So let's see. I'm going to use some space up here. So in order to find n1, I need to take 315 and divide it by 9. 9 into 31 is 3 times because that's 27. So, but I have to put it back here, no, right here. 3 times 9 is 27. I subtract, that's 4. I bring down the 5. Okay. So this is 35. So n1 equals 35. My first number equals 35. Now I know that they have to add to 63. So let's just do the work right here. 63 minus 35. 8. Why did I put a 2 there? That's fine. 5 minus 3 is 2. It's because I did it in my head. Almost always when I write down the wrong number, it's because my brain is busy calculating what to do with that number, and I write down part of the answer instead of the number that I should be writing down. See, that's why I put a 2. I canceled the 6 and I put a 2 because I already, in my brain, said, oh, 5 minus 3 is going to be 2. So I wrote it there. I get ahead of myself. And I probably did this as a student too. So, good advice, which you guys already know because you're really good at this. Slow down and write everything out carefully because it'll prevent those cookie mistakes. All right, did I do it right? 35 and 28, yay. Beautiful. This one was the hardest one because of this ratio presentation, so keep this in mind. When it says that two numbers are the ratio of each other, this is the format that we use. And then once you get this, you'll want to change the presentation of that by first cross-multiplying and then using some algebra, however you'd like, to get that into a form that you consider more useful. Okay? This one in particular, if you need to check the solutions manual to get kind of a game plan going when you're starting these problems, that's okay. You can also look at these problems either in the video again, or you can look in your book in lesson 90, because each of these 6 different examples probably parallels to a problem in the homework. So if you get a problem in the homework and you feel stuck, flip back to the beginning of lesson 90, which you'll be right there because you're doing the homework for 90, and look through the examples in the book and find one that looks like the problem you're trying to work, and see if that helps you remember how to set it up, because these are all frustratingly ever so slightly different, and that might make you foam at the mouth during your homework. I don't know. It's been a full moon. That could contribute as well. But in any case, this can be frustrating because there are so many subtle variations on the theme. However, you've got more than enough skills to conquer this. So, good luck. Carry on. I'll see you at lesson 91.